Lesson 3.1 introduces us to exponential functions. This whole chapter talks about exponentials, and we'll deal with a little bit of everything with them. But by definition, exponential function, f of x equals a times b to the x, where a is some non-zero number, so some value that is not zero. B is positive and cannot equal 1. Okay, this is your exponential function right here. F of x, or your form, exponential form. F of x equals a times b to the x. A is what we call the initial value, and b is what we call the base. So the a is the value out front, which is your initial. Your base is the value that has an exponent. Now, example 1. Determine whether each of the following are exponential functions. For those that are, we're going to be asked what the initial value and base are. For those that are not, we're going to talk about why not. So, example A. F of x equals 3 to the x. Is this an exponential function? If so, what are my initial value and base? Exponential function? 3. Does it fit the form?
No. There's no a. A is 1.
Could I rewrite this of the form? Is that equivalent?
Yeah.
3 to the x is equivalent to 1 times 3 to the x. So if we think about it that way, and we make that invisible 1 present, is this an exponential function? Yes. And I'm just going to say exponential. You can say yes if you want. Now, I shouldn't have circled that yet, because we need to talk about what's our initial value. Okay, and I'm going to write IV for initial value is 1. What's our base? Base is 3. Okay. You also might see, they might ask for A and B values. If so, your A is 1 and your B is 3. Okay? Good enough? Okay, what about B? G of x equals 6x to the negative 4th. Exponential or not? If it is, what are your initial value and base? If it's not, why not?
Yes. No.
I would say no, because negative exponent.
Sure.
I don't feel
Did
like
answer
it's
specify?
Yeah, that's true.
It could be 6 times x to the negative 4. Or does the exponent have to be an x?
I say, what are we overlooking here?
The exponent has to be x.
Yeah. This is exponential functions. What's in the exponent?
X.
Your variable, okay? In this case, x. So in example B, where's our x?
Not an exponent.
It's not an exponent, right? It's in the position of base, if you ask me. So not exponential because x is not the exponent. This is what, if you remember from last chapter, this is what I would call a power function, because it's x to some power. So not exponential.
Jeez.
And my reason is going to be x is not the exponent. Okay. C. H of x equals negative 2 times 1.5 to the x.
Yes.
Yes?
Yeah.
No. Yeah.
No.
Yeah. Yeah, because
It says
What's non-zero?
Pause.
Not zero.
Non-zero.
B is
Non-zero would be not zero. So
Okay.
anything except
But it's-
zero.
It is exponential.
But no, B is not positive.
B is
B is positive.
It is positive.
But it's a negative.
No.
Where do
A
you
is
get
a
the
negative.
from?
Oh.
Look at that.
Exponential.
Teamwork.
IV,
Okay.
-2,
Well, that's
base
just-
15.
So I am going to, I think we all agreed eventually. I am going to agree that this is exponential. Initial value
-2.
is the value multiplied by the exponential term, so -2. That initial value can be anything except 0. Why can't it be 0? Because if it's 0, this function doesn't
The whole
exist.
That's
thing
not a decimal.
Yeah. Okay. What's the base?
15. 1.
Technically 1.5. If you can read
Oh.
the not crazy,
That's
print, not good.
Two-
Negative 2.15.
No.
My head did?
That's a time.
Okay.
That's where I said that there's not a decimal.
That was.
I've had the point. If I get a chance, I'm going to redo these notes for next year. The copy quality is.
There was no
fine.
way to tell that was
had all her
1.5.
coffee today because I
There's the
actually
problem.
Spilled my coffee.
on accident. All over the
Okay.
keyboard.
D. D.
Find the keyboard word.
Exponential or not exponential?
See, now this is where it gets a little sketchy because it's a negative exponent. But
It never says.
It never says
that it
me
has
personally,
to
I'm
be
going to take my chances and go
I mean,
exponential.
but it's
Mario,
a
what are your
function in the
thoughts?
given function. It has
That's what I'm saying.
But it doesn't say that.
Are you guys gonna start arguing?
But we have
with
a
Sophie or
50
what?
chance of getting this right, so I'm going to go exponential.
Mario's
You go
gonna
the
go
other way.
not exponential.
See,
Okay, who's
so
right?
one of us is right.
That's how the world works. We always
So, okay. And I see both sides here.
In A.
There is the
I hope Mario's right.
initial piece that the exponent is a positive x up there. The question, and it doesn't really state, although I guess it never really stated that in an exponential function x is the exponent, but the question is there a way this could be rewritten?
Uh-huh.
In other words, kind of like up here, on A, there was a missing 1, yes? So it kind of didn't look exponential because we were missing that value, but it was really there. So what if we think of this? 2 to the -1 raised to the x. So there's still a 7 out there. But the idea of negative x, is it true that negative x is -1 times x?
Right.
Right? Okay, so what I'm trying to do here is I'm trying to separate it so there's just an x. So now I have the 7 out front, 2 to the -1st, raised to the x. Now let's talk about what is 2 to the -1st. What do you do with negative exponents?
Fraction.
Fractions.
It takes it to the
1/2.
denominator. And so what this then becomes is 7 times 1/2 to the x.
Does it have to be greater?
No, it says it cannot be 1 and it can't be negative, so I guess that checks
Okay,
out.
so now we get to the question of, okay, is that base legitimate base? Now that we have that positive x form, and b is positive, is my base positive? Yes. It doesn't equal 1, correct? So this does end up being exponential once we do a little work on it. If it's exponential, what is my initial value? 7. And what is my base? 1/2. Okay.
Not
E.
exponential.
Man, I didn't get to read the problem.
You can just look at it. It just looks wrong.
It just looks wrong.
It just looks
There's
wrong.
a pi. The math ain't math.
Okay, so why is this not exponential?
There's no x.
There's
And
pi.
there's pi.
Okay, there's a pi in the variable.
Pi sounds really good.
Is there an x in this problem at all?
Apple pie's
No.
No.
Who was talking?
Guys, this is just a constant. 5 times 6 to the pi, I don't know what that value is. That's just some number, okay? It's some number. There is no x in the exponent, so it is not exponential.
I put non for some reason.
No.
non.
No.
Well, I am using a complete thought here, full words, and saying not exponential.
I changed
And why is there not exponential?
X.
There is no variable, or x is not the exponent. I mean, you could go one of two ways with this. There's no variable in the problem, or there's no variable in the exponent. Both are valid arguments. Okay. Example 2. Okay, now we're going to talk about the fact on example 2 it says to find the exact value, which means put the calculators aside. We're not using them.
What?
Okay, a calculator is going to give you a rounded value often, okay, depending on the situation. This one's an exact value. So, for instance, if there's a square root in the problem, I don't want to know that the square root of 2 is 1.414. I want it left as square root of 2. Or, if there's a fraction in the problem, 1/3. I don't want to know that that's 0.333333 repeating because that's rounded. I want to know that it's 1/3. So when it says exact answers, you don't want to get a decimal equivalency on your calculator because you will get it wrong. So just kind of beware there that we are talking about exact values. Now, we'll start easy. Okay. F of 4, given that the original function, f of x, is 2 to the x. So what's that mean we're going to do here?
4 goes into X.
Okay, every place you see an x, you replace it with 4. And so this is going to be 2 to the 4th. We're not going to grab the calculators because we're going to use our brains.
Oh, scary.
It is a Monday.
2 times 2
64.
times 2
It's 16.
8.
times 2.
60. Yay.
Okay,
Did math.
that was doable.
I did that.
Okay, B. F of 0 means I'm going to do what?
2 to the
Place
0.
everything.
2 to the 0.
Isn't that just 1?
And this is a rule you're expected to know at this level.
Anything to the 0th power is a 1.
Anything raised to 0 power is 1.
It's actually a word.
0th power?
Look it up in the dictionary.
To the nth power.
Okay, C. F of negative 3
1 over 8.
means I'm doing,
0.125.
okay, hold on. You guys already done these on the calculators?
No,
No, like
I
I actually, I knew how to do that.
Right.
Okay.
I did it off the dome.
2 to the negative, so F of negative 3, putting in the negative 3 in place of x, yes?
Yes.
2 to the negative 3. Now, we just talked in that upper section. How do you deal with a negative exponent? To make a negative exponent positive,
Fraction.
you move it to the denominator, right? So then, this becomes 1 over 2 to the 3rd. And what do we know about 2 to the 3rd? It's 8. So I want 1/8 here.
Okay.
Okay? I'm not looking for a decimal. Now, in this case, if you give the full decimal, the 0.125, that is still an exact value because you didn't round it. However, a fraction makes me think you actually used your brain and not the calculator. So,
Do these even have a fraction to decimal, or like decimal fraction?
it's in the math menu. But you're not going to look at it right now because right now we're not using calculators.
Yeah, kind
So, okay, D, F of 1/2. Every place I see an X, I'm going to replace it with 1/2. So this is going to be 2 to the 1/2.
Is that when you just like divide? Not divide, but like,
Yeah, it's 1.
yeah. Oh well.
Okay, guys, go back to your Algebra 2 brains. We learned how to deal with rational exponents last year. It's less than a year ago because I believe it would have been second semester.
I was gonna say I thought I remembered doing these back from last year. But
What about a rational exponent? What does the denominator of an exponent tell me? The 1, the numerator is the power, so that's 2 to the 1st. The denominator,
Oh,
What's
it's like
it
the 2 to the 2nd and then square root, or is it 2 to the 1st and then square root?
What?
okay,
Yay.
so 2
Okay.
is under a radical. Your denominator is telling you the root. So since it's a denominator of 2, that's telling me to do a square root. The power of 1 is the power, the numerator of 1 is the power. So this is the square root of 2 to the first. Or in other words, this is the square root of 2. Now, you give me a decimal in this one, it's wrong. Because you cannot possibly actually write out the exact answer in decimal form. Because the square root of 2 is irrational.
I used the calculator.
Okay? So, and this is why we're not using a calculator. Because you put 0.141 or
Yeah, I think.
0.414,
Well, that's
okay, you're going to get it wrong. Because it asks for the exact value. Okay, put the calculator down.
what. I was just checking.
Okay, no, 1.414.
Yeah.
Sorry. I knew 0. I knew something I was saying was wrong. Okay, E. And I want you guys using a calculator on this one. I want us to use our brains.
Wait, everything but learn
Use
from
your
the negative.
F to the negative 3 halves says we're doing 2 to the negative 3 halves, right? Okay, let's start with the negative exponent. What's the negative exponent tell me to do? In the denominator. So it's going to be 1 over 2 to the positive 3 halves, yes? What's a fraction exponent tell me? This is going to be 1 over the what? Square root of 2 to the third. Now, we've made progress there. Officially, this is not how you should leave an answer with a radical. So first of all, what is 2 to the third? So this is 1 over the square root of 8. Okay, what did we learn about the square root of 8 back in Algebra 2?
It has a perfect
Has a perfect square in it.
square.
If it has a perfect square in it,
So then you simplify that, then it's 2 square root of 2.
okay.
Like a minus.
So 8 is 4 times 2. The square root of 4 is 2, and that's going to go outside. The other square root of 2 is not a perfect square. It stays under the radical. Now, this is simplified to an extent. Other than officially, we're not supposed to leave a radical in the denominator, right? How do you get rid of a radical 2 in the denominator? Well, I'm going to box that answer here in a moment as an option.
Alright.
How do we get rid of a radical in the denominator? You multiply by that same radical, if it's just a single radical. So we're going to multiply by square root of 2. What I do in the denominator, I do in the numerator. So, square root of 2 over 2 times the square root of 4. And what is 2 square root of 4? 2 times 2, which is 4. Now, I have both of these answers boxed on my paper. Regardless, they're both exact answers. Officially, the last one, no one's going to complain about that one because it is rationalized, it is simplified, it is as far as you can go. This one is not rationalized, but it's still a good answer. Okay, we're not always required to rationalize, it just kind of depends. Okay? Okay. Example 3 is the last example we need to get through for today, and then you'll have 1 through 14 that'll be due tomorrow, doing the similar type stuff. Okay? Example 3, use the following chart, determine the exponential function for f of x and g of x, and we also have a graph to do this on if we get a chance as well. So what is our exponential function form? From the top of the paper, f of x equals a times b to the x, which means we need an a value and a b value. So a will always occur when x is 0. A is your initial value, and assuming we are in proper exponential form, Your initial value happens when x is 0. So what is my initial value when x equals 0? 4. So, and we're just looking at f right now. G is a separate piece here, right? So this is for f. A is 4. And then your b value, your base, is how do we get from one term to the next in terms of multiplying? So how are we getting from 4/9 to 4/3? 4/3 to 4, 4 to 12, 12 to 36. If you start with the whole numbers, it's easier, right? How do we get from 4 to 12? Times 3. 12 to 36? Times 3. Does that hold true up at the top? This one's easiest first. 4/3 times 4. The 3's would cancel, or excuse me, 4/3 times 3. The 3's would cancel, you'd get 4, wouldn't you?
Yeah.
And if you check 4/9 times 3, a 3 would cancel, you'd get 4/3. So that 3 is my b value. So, can I write an equation now? We certainly can. So, for part A, I'm going to say f of x is 4 times 3 to the x. That is f of x. Okay. G of x, I'm going to look at over here on the right side. What's my a value?
8.
8.
Okay, and realize we're using the same x's from the beginning, yes? We just have new y values. So a is 8 because that's happening when x is 0. How are we moving here? How do we get from 128 to 32, 32 to 8, 8 to 2, 2 to 1/2? Divide by 4, okay? What if I say I need it in terms of multiplication? Yeah, and I'm not against saying, you know, oh, how do I get from 32 to 8? I divide by 4. However, we need the appropriate ratio. How are we multiplying? And this is where we remember dividing by 4 is the same as multiplying by the reciprocal, 1/4. And so if you check that, 8 times a fourth, guess what 8 times a fourth is? 2. 2 times a fourth is a half. And if you go back up here, 128 times a fourth is 32. Okay, so yes, it's dividing by 4, but we need it in terms of multiplication. So, if this is g of x equals a times b to the x, g of x is 8 times 1/4 to the x. You will notice I put parentheses around the fraction there. If we look at b real quick, gosh, those are really hard values to see, and I don't have them written in these notes, but if we look at these values, can you read them? Important one, what's this value here on the y-axis? If I make an xy chart here, that is 0, 3, yes? Technically, if this is true exponential function, we only need one more value, one more ordered pair. What's this look like? 1... Does that look like 1/6 to you?
Yeah.
Looks like 1/6 to me. And then 2/12. Okay, well, what's your a value? A is 3. How do we get from number to number?
Multiplying by 2.
Multiplying by 2, and so b is 2. They didn't give us a function form. I'm just going to say y equals 3 times 2 to the x. That could be f of x, that could be g of x, whatever the case is. Okay, for tomorrow, do the homework. I'm not doing the back of the notes right now. We'll kind of reconvene at the end of the chapter and see where I end up. Page 261.
261 or 255?
Sorry, what is it? 255? 1 through 14. I don't remember to write the new updated pages here. Don't forget phones. You did have them back there today for sure.